Magnetostrictive Materials, Applications and Challenges by Jacob Romero, Cortland Smalls, and Anthony Kennedy. Abstract. Magnetostriction is a change in shape of materials under the influence of an external magnetic field. In other words, magnetostrictive materials is heavily induced by magnetic fields, whether that be the change of shape, volume, or change in structure. This can be seen through scientific and engineering bases, the different engineering approaches that go into the material, and the context that this type of material brings out in global, economic, and environmental aspects. This will all be explained later on. How it works. Magnetostriction happens when the domains in the material partially align themselves with the field, and in turn change the shape of the material. The figures to the right shows how those rotations can change the length or volume. Most pure elements have relatively small magnetostriction. However, we can create alloys that have a much higher magnetostriction, and some can achieve their maximum length through relatively small fields. Magnetostrictive materials are widely used in the engineering profession. This includes being used in all the disciplines as well. In infrastructure applications, magnetostrictive materials are being used to improve hydraulic systems, to assist in electronic materials, and are now most recently being used in construction with magnetic fluids. Because of the technology of magnetostrictive materials has continued to flourish, their use in infrastructural applications is more ideal and more seen today. Ultimately, it does not matter what discipline of engineering you choose. The use of magnetostrictive materials can be applicable to all of them. Upon researching real-world applications, the magnetostrictive materials, the most common ones used are motors, hydraulic actuators, and sonar transducers. These are intriguing and fascinating applications to look into and require a multidisciplinary engineering approach in nearly all cases. However, not everything is always perfect. There are many challenges that come to magnetostrictive materials. These challenges are based off of the effects that are listed below, such as Joule magnetostriction, which changes the sample directions in the direction of the applied magnetic field, the Villari effect, which changes in magnetization due to applied stress, and magnetovolume effect, which changes in volume due to magnetization, and the Nagauka-Honda effect, which changes in magnetic state due to changes in volume. These are just a few challenges that engineers have to deal with when using this material. It's always important to realize this before going into a project.
Global and economic context. Although magnetostriction is a fairly new concept, some applications have been put on the market, such as these listed below. One of them being the ultrasonic scaler produced by Who Friendly, as seen in the photo. Although not found on the main retailer's site, this product has seen going for as much as $700, whereas similar tools have been found at cheaper cost, so there is room for cost-effective improvements. Similarly, the magnetostrictive digital engine oil level transducer has been found to go for $50 to $500, where there is also room for cost-effective improvements. Magnetostriction, the idea that you can change shape, volume, and structure, has found many applications in the current engineering design process. It has found uses in motors, hydraulic actuators, and sonar transducers. Magnetostriction is becoming ever more popular and is now being seen throughout global markets. Thank you for watching, and here are references as listed below.